Good morning. Today we are going to see the homogeneous catalysis. When we see the catalysis is the process in which the rate of the reaction will be increased and the percentage of the yield of that reaction will be increased. And there are two types of catalysis: homogeneous catalysis and heterogeneous catalysis. Today we are going to see the homogeneous catalysis. The phenomenon of changing the rate of chemical reaction by the action of substances that and do not alter their on chemical composition during this reaction is called catalysis. This term catalysis was first used by Berzelius in 1836. Catalysis plays a very important role in chemical industry. Nowadays, more than 95% of chemicals are produced via a process that includes at least one catalytic step. Catalysis are substances that speed up reactions by providing an alternative pathway for the breaking and making of bonds. Catalysts are open specific for one specific reaction. If catalytic activity is improved, it may be possible to lower the temperature and pressure at which the process operates and thus save fuel, which is one of the major factors of cost in a large-scale chemical industry. In homogeneous catalysis, the reaction mixture and the catalysts are either in a liquid or in the gaseous state, or sometimes even in a solid state. Enzymes are examples of homogeneous catalysis. Homogeneous catalysts are in the same state or phase as the reactants, whereas the heterogeneous catalysts are not in the same state or phase as the reactants. Homogeneous catalysts are less frequently used in industries, and heterogeneous catalysts. This is because on completion of the reaction, the catalyst have to be separated from the product, and this process is very expensive. However, there are a number of industrial processes that are catalyzed homogeneous repeatedly using acids or base. For example, manufacture of ethane 1,2-diol from epoxy ethane, where the catalyst is a trace of acid. Now we are going to see the definition, types and properties of homogeneous catalysis. First, see the definition. Homogeneous catalysis are catalytic reaction in which the catalyst is in the same phase as the reactant. It is generally a catalysis in a solution by a soluble catalyst. A portion is A proton is the main universal homogeneous catalyst. This is because water is the most common solvent and it forms protons by the process of self-ionization of water. Types of catalysis. Homogeneous catalysis have the following types. When the catalyst and the reacting substances are present together in a single state or phase of matter, usually as a gas or liquid, it is customarily classified the reactions as case or types of homogeneous catalysis. Type 1. In this type of catalysis, reactants as well as catalysts are in gaseous phase. For example, oxides of nitrogen, that is NO and NO2, acts as catalyst for the oxidation of SO2 to SO3. In the lead chamber process for the manufacture of sulfuric acid, here the reactants SO2 and O2 and the catalyst NO, NO2 all are in gaseous state. Another example of this type is the destruction of ozone in the atmosphere catalyzed by chlorofluorocarbon. Here, ozone as well as chlorofluorocarbon both are in gaseous state. Type 2. In this type of catalyst, reactants as well as the catalyst are in a liquid state. For example, sulfuric acid is used as a catalyst for the formation of diethyl ether from ethyl alcohol. Here, the reactant ethyl alcohol and the product diethyl ether and water and the catalyst sulfuric acid all are in liquid state. Type 3. In this type of catalysis, reactants and catalysts are in solution state. For example, in the redox reaction, iodide ions are oxidized by persulfate ions and Fe2 or Fe3 ions in solution acts as catalyst. Here the reactants persulfate ion, iodide ions and the catalysts Fe2 or Fe3 ions all are in solution. Type 4. In this type of catalysis, acids or bases acts as catalyst. Accordingly, Bronsted and acid is a molecule that can give a proton and base is a molecule that take up a proton or accept a proton. On these assumptions, the range of acids includes bisulfate ions HSO4 1-, acetic acid, water, hydronium ion H3O plus, and ammonium ion NH4 plus. The corresponding bases are sulfate ion SO4 2-, acetate ion CH3 COO-, hydroxide ion OH-, water H2O, and ammonia NH3. These acid-base catalyzed reactions includes first the acid catalyzed hydrolysis of an ester ethyl orthoacetate. Second, the basic catalysis of the conversion of glucose to closely related form. Type 4 reactions can also be classified under type 1 or type 2 or type 3 reactions. Properties of homogeneous catalysis or catalysts. First, they are consumed during the chemical reactions. Second, they increase the energy of the reactants. Third, they offer a high degree of interaction between catalyst and reactants molecules. Fourth, they lower the energy of activation of reaction. Fifth, they increase the rate of reaction without increase of temperature. Sixth, they shift the equilibrium to favor the formation of products. Thank you.